Hello, my dear students. Welcome back to the lecture. In this lecture, we will see how the PCC has to be laid and what is quality check, how it has to be done. So before that, a small thing we'll try to understand. Now, see, all these are the footings that were excavated, isn't it? Now, how many footings are there? There are more than 10 footings here. Let us count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, almost 12 footings are there. So while working in a bigger projects, more than 100 footings will be there to be excavated. Of course, it's a very small house project. When we start to work on the industrial projects, when it's a very big apartments, or let us say it's a huge industrial structure, in that case, we'll be having a lot of foundations to be done. So as a site engineer, we need to do the planning accordingly so as to achieve the target and see to it that no vehicle movement is hindered. So we'll come to this point. What exactly do I mean by this? So now let us consider. I'll show you one of the drawing and then we'll come back to this. Okay. So what exactly I'm trying to tell you is, for example, let us consider I'm working on a project and this is a footing what I have. So try to count how many footings are there. So hardly there are like 20 or 22 footings, not more than that. So in this case, we don't have any issue with this. But so what I'm going to do, how I'm going to plan. So let us say tomorrow I'm starting with my excavation. I'm going to do the excavation up to this part. Okay. After 2 days, I'm going to do the excavation of the remaining footings up to here. Then I'm going to do the excavation of this another 3 footings. Then I'm going to do the excavation here, right? So it's a small project and overall we have a good area so that if you want to bring in your vehicle and all, it can pass. Because why I'm trying to tell, once we do the excavation, it's very difficult for the movement of your vehicle, isn't it? So you have to plan accordingly. Now, since it's a small project, it's okay. We can manage somehow. But now imagine a situation that you have been working, okay, that you're working on such a big project. Let me show you the big project. So you can see a lot of footings here. Everything is a footing here. So just try to understand. See, so this is C6 footing, C7. I mean, this is a F25, F26, F25, F26. Everywhere there's a footing. Now you can't keep on excavating the way you like. Let us say today you excavated this much part. Tomorrow you're going to excavate here. Again, if you're going to excavate here, then what will happen? It's difficult since it's a very big project. A lot of vehicle will come and go, right? For different items, different vehicles is going to come. So we cannot do excavation in that. For that, we have to do proper planning. So how do you do the planning? I'll explain you that, right? Yeah. So we'll understand this through a small animation. Let us say this is a one excavation you have done, second, third, and whatever excavation you have done, whatever soil you have got, no, you have stored it here itself. Okay. In the same way, you have done the excavation for the next 3 footings, and also you have stored the soil here. So next, again, what you did on the next day, let us say this is day 1, this is your day 2. On the day 3, again you did the excavation here. Again you stored the soil here itself. Then again on the 4th day you did 3 footing excavation. You stored the soil here itself. Again next you did excavation up to here and you stored the soil here itself, right? Yeah. Now let us say once you've done the excavation, you want the RMC truck, that is a transit mixer, to come and place the concrete. Let us say on this particular footing here itself, you want to place the concrete. Now, once you call this RMC truck, what will happen? It will come up to here. After that, you already stored the soil here. Now, what will happen? This vehicle we cannot go from here. Again, here it will be a problem for you to place the concrete. Again, here it will be a problem for you to place the concrete. In the same way, here also, if you bring in the RMC truck, that is a transit mixer, it can place the concrete here, it can place the concrete here, but again it cannot go here because you already stored the soil. So you have done the excavation what you were supposed to do, but you did not plan it properly, because when the transit mixer came, it was very difficult for the transit mixer to make a movement. So you didn't plan it properly. Now what is the right way of planning? So this is wrong planning. The right way would have been, so you do the excavation and then you don't store it immediately here. Instead of storing the soil immediately here, what you do, you try to give certain gap between that. Let us say at least a 1 meter or 1.5 meter gap, and you store the soil here. Okay. Then again on next day you did a excavation for the next 3 footings, you store the soil here. After that I won't be doing any excavation here. I'll go to the last footings here, that is I'll do the excavation of this 3 footing and I'll store the soil here. I'll do the excavation of this 3 footing and I'm going to store the soil here. Now we have done less excavation, but that is okay. But now what will happen if I want to place a concrete, or let us say a PCC, to this particular concrete, I mean to this particular pit, I can call in the transit mixer and it can go easily throughout, right? In the same way, if I want to do the PCC for this 6 footings, easily my transit mixer can come and it can place the concrete. So here there is no hindrance to the movement of the vehicle. That is why I told in the beginning of the lecture, right? So this is the right way of planning. So why did I tell that? If it is a small project, something like this, here we hardly have 23 footings. So how do you plan? Okay, today we'll say we'll do the excavation of this 4 footing. Next we'll do the excavation of this 4 footing. Then we'll do the excavation of this 4 footing. Then we'll do here. Again, it's a small project. We'll be not calling the transit mixer and all. Normal laborers can do the PCC or other activities, and there is no much problem with the movement of the vehicle. But as I mentioned, I show you one of the very large project. I'll show you one more project. Now imagine you have been working, you started to work on this project. Again, you see here how many footings are there? A lot of footings, isn't it? Everything is a footing here. So you can see it. So you can see the footings here. Everywhere it is a footing. So in this way, again, how you are going to plan? So what you're supposed to do is, let us say today you are going to do the excavation of this, all these footings. Let us say these 5 footings you are going to do the excavation. You'll store the soil somewhere here. Okay. After that, next day, tomorrow, let us say you have done the excavation of these 5 footings. Got it? So the middle portion, you are not going to excavate it. Now, in the middle portion, you can make the movement of your vehicle and other activities you can carry out here. So once you do the excavation, you'll put the PCC, you're going to put the concreting for the footing, then the column concreting will be done, then the backfilling will be done. Once the backfilling is done, that means once the soil goes back into the pit, next what you can do after that, that will take around 10 days process. It's a complete 10-day process. And from there again, what you're supposed to do, next you are going to do the excavation of these footings, right? Now what will happen, you'll be having a space here for the movement of a vehicle and all. Next you're going to start from here, right? So in this way you have to do the planning of your excavation, right? Yeah. So yeah, that is why always you have to plan your project. So failing to plan is planning to fail, right? So always whenever you take up any projects, you are supposed to do the planning, right? Otherwise what will happen if you don't plan in this way? Let us say whenever we take up any projects, we'll be given a start date and we'll be given an end date, right? So we have to hand over the project within the end date. If you delay the project, then the client is going to impose the fine on you. All those things will be written in the contract document. Now let us say you took a project and you didn't plan all these things, like per day how many footings you are going to do the excavation, after how many days of excavation you are going to do the PCC one, after how many days of PCC you are going to do the footing reinforcement. And if you don't plan which day what footing has to be done, if you try to execute everything at once, later what will happen, you will be in a trouble. So always you have to plan a project. Now since I'm telling a word called as planning, I'll come a bit later, not now, maybe after 1 or 2 lectures, I'll tell you how this planning has to be done, at least a baseline schedule on a MSP, or sorry, on a Microsoft Excel, and we'll try to understand how it has to be done. So to make you more curious, I'll give you a small outline. So this is called as planning. In the planning, we'll try to write when my earthquake excavation will happen, when my PCC is going to happen, when the reinforcement is going to happen. I'm going to write a start date. I'm going to give an end date to that, right? All these things we'll try to understand in the upcoming lectures. Right now, we'll stop up to here. And next, we'll go to the next process, that is about the laying of PCC. So we'll see what is laying of PCC. So next is PCC stand for plain cement concrete, which you already understood. And usually the grade of a concrete that we're supposed to use for the PCC, it is M10. M10 most of the case. We know where M is a mix and 10 is a characteristic compressive strength of that particular concrete. A layer of PCC is usually 75 to 100 mm, which is laid on the ground to get a uniform surface, and the area where footing, rebar or mesh to be laid is free from dust and debris. Second, imagine PCC layer is like a blanket. Most of the times when we sit down, we spread a cloth or a blanket so that no dust gets collected on our clothes or body. That means, see, you have done the excavation and you have done that proper ramming. Now what we are supposed to do, we are going to put the PCC. Now the first question is that why this PCC has to be put. See, whenever we do the excavation, even we do the ramming activity, there's a slight variation in the level of your ground. That means your that the soil will not be uniform. There might be slight variation. If there is a slight variation, when we keep the reinforcement mesh over that, when the mesh also there will be slight variation. I don't want that to happen. To get a uniform surface, I'm going to put a PCC. That is the first objective. Second is that, let us say you're not putting a PCC. Directly if I keep the reinforcement bar of the footing here, then what will happen? Yeah, so if I directly keep the reinforcement mesh, so if you don't know what is mesh, a mesh will look something like this. Let me do that. So once you place the reinforcement mesh, you're going to keep the reinforcement mesh in this way for the footing. Okay. So if you don't put the PCC, what is happening? This reinforcement mesh, that is a rebar, you're directly exposing it on the soil. And in the soil, there may be some foreign materials, or let us say there may be sulfates, chlorides, and all. Again, that will come in contact with the rebar, that will come in contact with the concrete, right? Again, there may be a reaction between them. As a result of that, there might be a corrosion in the rebar, and if there is a corrosion in the rebar, the durability aspects is going to come down. So I don't want all that to happen. So that is why I'm going to give a certain layer of a concrete, which we call it as plain cement concrete. Hence PCC is given. Now in the PCC, you are not going to put any reinforcement, hence we call it as PCC. If you're putting a reinforcement in that, we call it as a RCC, right? Yeah. So in the same way, whenever we sit down, isn't it? We don't want the dust to get collected on our cloth. We just put a, we just spread a cloth, and over that we try to sit. So that cloth, what we put, no, it's like, it will act like a blanket for us. In the same way, in a building construction, it is called as PCC. Okay. Yeah. So once you put the PCC, you can see we have put the concrete here. This is how your PCC bed is. We call this as a PCC bed. So you can see 1, 2, 3. In this way, 4 PCC bed we have put. Okay, you can see it here. So you have prepared this formwork. All this formwork you can see, and then you are going to place the concrete over that. So this PCC, sometimes we call it as a plum concrete. So write it here. So remember, plum concrete. So why it is called as plum concrete? Because the ratio is somewhere close to 1:4:8. So here this aggregate, the last one is 8 is aggregate. The coarse aggregate content will be more here. So it will be a kind of a lean mix for us. Okay. So that is why we call it as a plum concrete. The second thing, which is very important, only in the PCC, the coarse aggregate, what we are going to use, no, we are going to use it as 40 mm size, 40 mm. That is a bigger stones we are going to use here. You can see a lot of bigger stones here. If you just observe here, you can see a kind of a bigger stones here that are coarse aggregate. You can see here also, right? So that the size of that is 40 mm. Whereas in the normal RCC structure, for a footing, for column, for slab, we use M20. So they may ask you in the interview sometime, what is the size of the aggregate that you're going to use in a PCC? So you can tell 40 mm is the size of the aggregate what we try to use. But in the normal footing and other RCC work, we are going to use only 20 mm aggregate and not more than that. Yeah. Right. Finally, you can see this guy, how he has put the PCC. And finally, this is a finished PCC, how it looks. Once you do all the finishing activity, this is your PCC. So for the same project, you can see the one where we had understood the total station, they have done the excavation here. Okay. And once the excavation is done, they are preparing the coarse aggregate. They have a sand ready here, and then they are going to place in the PCC here. So in the same way, it's the same thing here. Now, what should be the thickness of the PCC, from where we are going to get? Again, that will be mentioned in the structural drawing. I've taken one particular image of that. Don't try to concentrate anywhere. You just concentrate here. What is written here? 75 mm lean concrete. Again, lean concrete and PCC both are one and the same. Few people call it as plum concrete. All three means same thing. Some people call this as bed concrete. Again, it's the same thing. You can call it as PCC. You can call it as lean concrete. You can call it as plum concrete. You can call it as bed concrete. All are one and the same. So what is written? 75 mm you have to give. That is a thickness of that. 75 mm comes out to be 3 inches. So when we arrange the formwork, if you can see the formwork here, so this formwork, no, whatever we have arranged, so this is 3 inches. The height will be 3 inches, and whatever height we have maintained, throughout that we are going to pour in the concrete. You can see it here, right? It's written 75 mm lean concrete is written here, right? Yeah. So now you can see here, this is how they have prepared it. And now you can see everywhere, this is at 75 mm. This is at 75 mm. Everywhere they are going to keep. And this is how the 75 mm is prepared on the ground, right? Now, one more thing you need to understand. See, now this is a very big area, isn't it? This area, what you can see, it's a very big area. So, but you want to get a very uniform surface. Then how do you make it in a proper or a uniform shape? So you can see a lot of rebar has been pegged here. There's one rebar pegged here. One rebar, they have pegged it here. Then they have another rebar which is pegged here, right? So on all the rebar, they have done the small marking of that 3 inches. and through that they'll come to a conclusion, okay, they have to stop the concreting up to that level, isn't it? So that means what I'm trying to tell is, you can see here they are going to, you can see a kind of a small thread here. So this thread, they have marked it everywhere, and whenever the mason tries to do the leveling, no, he'll come to a conclusion that this is a 3 inch and this is where I have to do the finished surface. Similarly, I'll show you one more. So see it here, this guy is fixing that. Okay, you can see this guy is fixing that 75 mm height what you require in the PCC. Everywhere you can see, again, auto level we know how to do. Anyhow, I'll explain you how to take the PCC top level. We already understood the excavation level, how it has to be understood. Once you pour the PCC, the top level also you're supposed to check. We'll see how it has to be checked. So this guy is holding auto level and is giving that top of that level. That's the one way of. Second way is that how you can do. The second way is that what you're supposed to do, you have to mark this 75 mm somewhere, like let us say I'm marking it here. Okay, so this level is my 75 mm. So once you mark it here, if you don't have a total station, we get something called as water tube. Okay, water tube in the sense whatever tube you have to fill in the water, and through that you can transfer the level. So what you're supposed to do, once you get the tube level, you have to place one end of a tube level here, and wherever you want to transfer it, let us say I want to transfer the level here, then the other end of the tube you have to hold it here. So one end will be here, the other end will somewhere here, and here whatever bubble you are going to get, no, that is your 75 mm, and the same bubble you are going to get here also. So wherever that bubble stops, no, that itself is a level. So in this way, with reference to this red color, we'll try to, after that, once you transfer it here, here also you have to, here also you are going to get that red color, here also you're going to get that red color, right? Now again, let us say I want to transfer the level here. Again, what I'm supposed to do, again, I'll be holding the one end of the tube here, I'll bring the other end of the tube somewhere here, and I'll stop it. So once I stop it, the bubble will try to go and up and down, and at one particular state it's going to stop somewhere. The place where it's going to stop, that itself will my 75 mm marking. Maybe that let us consider it has stopped somewhere here, and that itself is a level of a PCC. So in this way, throughout that formwork, we are going to transfer the level so that we are going to get a uniform surface, right? Anyhow, how to transfer the tube level, all these things we'll be seeing in the upcoming lectures. Since PCC is not that very good, I mean, we don't have to concentrate so much on the PCC, so we'll not do it here, but I've explained you how it has to be done. Yeah. So now once everything is done, next is we have to place the concrete, because we have seen how the formwork is done. So before placing the concrete, we have something called as quality check. You might have seen on any of the products and all, you can see it is written QC passed, quality control passed, right? In the same way, when we work in the bigger construction project, we have a person called as quality engineer. So before we do the concreting, he is going to come and check whether the work we have done is correct or not. So that is why we have certain checklist for that. We'll try to see what exactly our checklist is, and then we'll proceed further. So I'll show you one of the checklist now. So you can see here what is written: checklist for laying plain cement concrete. So this is a description. Check for the completion of preceding activities for the area to be concreted. Check for the formwork and dimension. Is it okay? That means he's asking us whether the formwork what you have put for the PCC, whether it is according to the dimension or not. So we know the dimension from the structural drawing. If I go back here, let us say, this was the dimension what we wanted. Okay, inner to inner dimension, and this inner to inner dimension. I'll take some random value. Let us say this was 3 meter here, and this was 4 meter here, right? So that you have to do exactly. Then once it is done, you have to check the diagonal also, because now how you check the diagonal, you should check from this end to this diagonal how much you should get. We know that it is 3 4, and this has to be 5. So that also, as a site engineer, you need to check. So a quality engineer will come and check all these things. Only then he's going to allow you to pour the concrete, because when we work in bigger construction companies, we want quality standards to be maintained. So that is how it has to be done. So everything, all the alignment you have to check, and after that, this 3 4 5 method also we are going to check to make sure whatever sizes we have given, that is exactly correct or not. You're getting my point? So in this way, we'll be having a checklist. So that is why in the checklist they have written it here. Check for the formwork and dimension, is it okay or not? If it is okay, you are a site engineer, then what you're going to do, you're going to mark it here. Okay, all right. Here also everything is right. Next is again what is written: provision for the working condition of the concrete, whether you're making use of the vibrator or not, whether the needle of a vibrator is correct or not, whether you're making use of a mixer machine. Like for example, if you check here, these people are using a mixer machine, isn't it? So this is through a mixer machine, they are going to place in the concrete. Now you have to check whether a mixer machine is okay or not, right? All those things will be mentioned in the mentioned in the checklist, and based on that we are going to do. Next is during the, now this is before concreting. Even before you're placing the concreting, these are the checklist you need to check. Next is at the time of concreting, once you're placing the PCC, what are the check for the mixed proportion. What is a mixed proportion? It was given in the structural drawing that we have to provide 1:4:8. That means if I take you one of the drawing, see here. So this is a typical cross section. It is written 75 mm lean concrete. What is written here? 1:4:8. This is a ratio that you are supposed to maintain. In the same way, if I take you to one more structural drawing, so this is one more here, and what is written here? You can see PCC is written. The grade is 1:4:8, and what is the thickness? It is again 4-inch thickness. So all those things will be written in a structural drawing. So again, based on that, you have to say, okay, whatever check mix ratio was written in the structural drawing, the same is being executed on the side. Check for the placement and compaction. Is it okay? That is at the time of concreting, they're going to place the concrete, isn't it? You have to check whether properly it has been placed or not, whether they are properly compacted or not. So you can see it in one of the image how they are doing the compaction. See, this guy is doing this compaction, isn't it? So properly you have to compact it, because there the cement content will be very less. It's a lean concrete and lot of coarse aggregate will be there. So properly you have to do the compaction there. Okay. Next is what is written again. Yeah, check for the finish level. Is it specified? Check for the surface finish. Is it acceptable? That means once you finish the concreting for the PCC, you have to check the top surface. Whatever marking you have done with the help of tube level or water level, whether the same level you have got or not. That also you have to check it here. And also the finish surface. The finish surface should be very good. Not too much good, since it's a PCC. At least it should be uniform. The main intention of putting a PCC was to get a uniform surface, right? If the PCC itself is non-uniform, there's no, that doesn't make any sense. So once you finish the PCC, you have to see whether the top surface is exactly horizontal or not. Again, that is mentioned in the checklist. You can see it here. Yeah, check for the surface finish, check for the finish level. So once this is done, after the concreting, we are supposed to do the curing. So what is curing? We'll see all that thing at the time of footing, but just understand curing is nothing but we have to we have to pour the water over the concrete once the concreting is done. So that is called as curing. So again, after concreting, like today, if I have done the PCC, tomorrow I'll take out the shuttering, whatever formwork I had kept, and I'm going to pour in the water. So that is called as curing. And why it has to be done, all those things we'll try to see in the upcoming lectures. Yeah, so I hope concepts are clear up to here. So we have understood what is PCC, how it has to be applied, what are the quality checklists that we are supposed to look in. Now finally, this is how your PCC looks. This is the next day. You can see these people had kept the runners. Okay, I'm showing you different images, don't get confused. See, these people had kept one runner here, they had kept another runner here, then he had kept another one here, then another one. So once you placed in the PCC, next day once the concrete gets set, they came and they removed all this PCC. You can see this PCC has been removed, and also they have done the watering. You can see this much portion is wet here, isn't it? They have done the curing of this, right? Yeah, similarly you can see it here. Now don't get confused about this A1, A1, 1 dash, P7 and all. We'll come to that a bit later. Just concentrate on the PCC, right? So this is a PCC that we wanted, and this is how we have got a PCC. Again, we know whenever we put a PCC, make sure we are taking the extra space, isn't it? If, for example, if you concentrate here, this was the size of the footing what we actually wanted. This one, this one, this one, and this one. But where we have done that casting, we have taken the axis, that is a PCC offset. This is 75, this is 75, 75 here, and 75 here. Got it? So that is why your PCC is looking big. But once you put the footing, your footing will be exactly on this marking, whatever marking they have done. We'll see that how that marking has to be done later. Yeah. So this is that PCC. Once it is removed, you can see a good PCC has come here. Here the finish surface is not that great, isn't it? See here a lot of coarse aggregate you can see, but you should do it properly. Yeah. So this is that particular project we were looking at. Now these people also have placed a concrete here. Again, you see here, these people also have placed the concrete here. With this, they are going to do the ramming. And finally, this is how it is done. And finally, once it is done for that particular project, this is how it looks completely. They have done the PCC everywhere. You can see here also they have done the PCC completely. Got it? So in this way, you have to understand how it has to be done. Now we missed one thing, that is this checklist what I'm speaking, right? Actually, we were supposed to look the checklist even for the excavation, checklist for the excavation in the soil, but I did not explain you. Quickly, we'll go through this. What is written? Is the excavation plan prepared? Is the layout, alignment, and size of the excavation marked on the ground as per the excavation plan? We had already marked it. This is the center line. We had taken the PCC offset. We had taken the working space. Everything we had marked according to the quality. Then, as a site engineer, what you're supposed to do, you're going to check it here. You say everything is correct. We have done it. Okay. Are there any underground utilities like sewers, water lines, cables, etc.? Okay, that is when you work in a bigger construction project and all, sometimes what will happen, there may be underground pipes of government projects and all, so you need to make sure that you're not damaging that. Is the area to be excavated clean and cleared of bushes, vegetation? Of course we did it, because in the first itself what we had done, we had done the cleaning of the trees and small plants and all, we already done that. So according to the quality of working. Next, check whether the barricading and caution signs are provided for deep excavation. Of course we are done. If you remember, in the beginning itself I told you, once we do the excavation, we are supposed to do the barricading and all, that also we have done. Then again, what the checklist reads, we'll try to quickly finish it. Okay, are the danger signs provided near the excavated? Of course we have seen that deep excavation, and that board sign also we are going to keep it there. Okay, after that, yeah, check for dewatering arrangement of waterlogged area. Is it okay? So I'll tell you one practical example of this. So for this particular footing, right, for this particular project, when we were doing the excavation, a lot of water was coming, because this particular project was very close to the sea. So what we used to do, we used to get in the pump, and whatever water you can see here, right, we were trying to take the water out with the help of a pump. This is what we had done. So that is why in the checklist they know all those things, that certain things will happen in a construction project. That is why they're asking, check for dewatering arrangements of waterlogged area. Is it okay or not? So that is why when we did the final PCC for this particular work, so here you can see everything, the water has been dewatered, isn't it? Initially there was water, but there is no water, and slight water is there, but we'll try to dewater all these things. We did dewatering for that complete project, right? So when we were pouring the concrete, there is no water. This much water is enough, not an issue. Okay, finally we had removed all the water. Got it? So in this way, all the checklist will be given. I'll upload the checklist of this. And finally, you have to write this control lines, soil tap at the foundation level. That will be mentioned in the geotechnical report. What is NGL level? What is the foundation level? What is the depth of excavation? For our project, what was the depth of excavation? For that particular project, we had an excavation of, let us say, 3.2 meter. I'll write 3.2. And if I refer one more drawing, for example, we had this particular drawing. So in this particular drawing, the depth of excavation was how much? 1.5 meter from here to here. The depth of excavation was 1.5 meter. So as a site engineer, I'll write it here that the depth of excavation was 1.5 meter for me. Okay. All these are the checklist that you different companies will have their different checklist. I'm showing you one checklist out of it. Then the foundation level, what is the foundation level that you're supposed to write? Natural ground level and soil tap at the foundation level. Got it? So in this way, all this checklist you have to do. Whichever is whichever is associated with your project, you have to just tick here. Something which is not associated, you can say not applicable. For example, let us say, yeah, our joint inspection records complete, not this. We'll take something. Yeah, for example, let us say, are there any underground utilities like sewers, water pipes, cables, etc.? If yes, then bring to the notice of the site in charge and take adequate measures while excavation. Let us say this is not applicable to our area. We don't have any sewer lines or water pipes. In that case, I'll say NA, that is not applicable, right? So I hope in this way, we are supposed to do all the work, right? We are supposed to do the work in this way. And finally, this is how your PCC is going to look. So I hope you enjoyed the lecture up to here. So we'll see you back in the next lecture. Thank you.